Hi friends, welcome back to Unit 3, Day 4 notes. This one we're going to focus on the end behavior of a polynomial graph. This is something that I took from kind of an activity from Desmos. When you think about certain types of graphs, for this one we have what the ends of the graphs do. So I'm not so much caring about the middle of the graph. So the middle of the graph is essentially like ups and downs, as long as it's polynomial. Ups and downs, things like that. I'm going to try and focus a little bit better. There we go. Essentially what's happening here is that the ends of the graph is up and up. The ends of this graph are down and down. Then I have down and up, and then up and down. And this is talking from the left and then the right-hand side. So this example here, for this one, this is an even degree, and then it has a positive leading coefficient, which I'll abbreviate LC. And then the other example with an even degree is this one here. And then this one just has a negative leading coefficient. Notice that these are in standard form so that the degree of the polynomial is like the largest degree is always first. In this next one, these two are both odd degrees. This one here has a positive leading coefficient. And this one has a negative leading coefficient. So again, essentially what's happening is that this is true for all scenarios, depending on if it's even degree or odd degree. If it's even degree, then whatever it is the same. It's either up, up, or down, down. If it's odd degree, then it's opposite. One's down and one's up. And then it just depends if the term is positive as a leading coefficient or a negative as a leading coefficient. So here, I want to know the end behavior and the y-intercept. Ooh, y-intercept, without actually graphing it. So here we just need to look at the leading coefficient of this. So 0.5 x to the fourth. This is in standard form. Check that first. Check to make sure it's in standard form first. So this one is a positive with an even leading coefficient. So the end behavior. And then this one, you'll see often written like this as your x value approaches negative infinity. Your y value approaches, now in this example, it's up. So this is positive infinity. So this is, remember, this is up and up. And then as x value approaches infinity, your y value also approaches infinity. So what do I mean when x approaches negative infinity and infinity? As x approaches negative infinity, think about what's happening on the number line. So as x approaches negative infinity, you're going left on the number line, so you're continuing to go that left direction. As you continue to go that left direction, it continues to climb, gets higher. So that's why we're saying it approaches infinity. Same as x approaches infinity, so as you move to the right on the number line, then your y value approaches infinity as well. And then it says this once the y-intercept without actually graphing. This one's a little bit tricky, but remember it's in standard form, so the y-intercept is always going to be your last constant with an x value of 0. And the reason that is because when we plug in 0 to all these x values, they're going to 0 out, and you're just left with the 6. So your x-intercept is 6, like that. With 2b, here we have a negative leading coefficient with an odd degree polynomial. So a negative leading coefficient with an odd degree polynomial means that it's going to be up and then down. This one is the one that students commonly miss. It's because it's counterintuitive to the way a lot of students think. So as x approaches negative infinity, so as my values of x get smaller, my y values are actually increasing. So I have y approaching infinity. As x approaches infinity, your y values get smaller, so this actually approaches negative infinity. It's going down, decreasing. And then this one, similar to the other one, if I want to find the y-intercept, I get negative 3. Talking about multiplicity, attributes of polynomial graphs with zeros and multiplicity, I'll do that in the next video. Join me then. Have a great day.